I told you that a set can have anything as its members, right? It could have Charles, the planet Earth, the number 5, and Concordia University, okay, as its members. But it's kind of just random, right? And usually when we talk about sets, we talk in math and our use of them, we're going to want to talk about kind of a coherent domain, like sets of numbers, or the sets of the whole numbers, or the sets of integers, or something like that. And so what we do is I'm going to use, because the letter U looks so much like the union symbol, we're going to use a capital V, okay? And V is going to be a special set that we're going to call the universal set, okay? And the universal set, remember the empty set we said is always the empty set. It's always the set that has no elements. The universal set defines what's sometimes called the universe of discourse. The things that you happen to be interested in talking about. Right? The set of things in my fridge. The set of students in my class. The set of students in the university. The set of, I don't know, brands of shoes sold at that store. Right? So you have the universal set depends on, or is the set of all things in the universe of discourse. Okay? The stuff that you're interested in talking about for the moment. Okay? So if the universe of discourse might be the positive integers. Okay, so 1, 2, 3, 4, blah, 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 blah. Okay? And so on. And then you can take subsets of that universe of discourse, and you could take the even integers. Okay? And you could take 2, 4, even positive integers. 6, 8, blah, 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 blah. Okay? And so you've got this set, let's call it E for even, and E is a subset of the universal set, which for now is the positive integers. Okay? But we might also want to talk about what's left when you take away the even ones. What's left? When you take away the even numbers from all the integers? The odd ones. Okay? So we could just list them. We could say the odd ones are 1, 3, 5, and so on, right? But it's kind of intuitive that we've got a set that contains a bunch of things, and we could get rid of some of the members. We're introducing the idea of set subtraction. Okay? So you take the set of all the integers, all the positive integers, you subtract the set of even integers, it's going to give us the set of odd integers in this case. Okay? And it turns out that if we subtract the set of odd ones, we're going to get the set of even ones. Okay? So when we have a universal set like this, and we take away some, what's left is called the complement set. Okay? The complement isn't like, oh, what a nice dress you're wearing. It's the complement, that's with an I, right? This is complement with an E. Okay? And this is easy to remember because complement with an E is related to this word, complete. And the idea is that you take a set, okay, A, and its complement, sometimes we call it A prime or A bar or different ways of writing it like that. Let's just use A prime. Okay? And so the idea is that together, if you take the union of a set and its complement, what do you get? If you take everything that's in one and everything that's in the other, what do you end up with? Yeah. So a set unioned with its complement is the universal set. Right? It's all the stuff that I took away and all the stuff that I left behind gives us all the stuff. Okay? And we can learn some other things about complements. What's the intersection of a set with its complement? So what's the end? So if I have set A and I intersect it with its complement, what's it going to be? Yeah, it's always going to be the empty set, right? Because it's all the stuff I took away and everything that was left. And so it's the empty set, right? Okay. So what's the complement of the empty set? What's the complement? So the empty set is this symbol. I don't know if people actually write this, but that's the complement of the empty set. Yeah, it's everything that's in the universal set that's not in the empty set. There's nothing in the empty set, so the complement of the empty set has to be the universal set. Right? Or another way to do it is take the universal set, subtract the empty set from it, and you didn't take away anything, and so you get the universal set. So why am I doing this? Just to give you some hope that we're actually going to do some phonology at some point. Have you ever seen this string of letters in a linguistics class? Where? In intro, like the third week of intro, or fourth week. Everybody took intro?
Yeah.
Think about these guys. Yeah. Oh, you make believe that now you get it. What is it? What do you know about allophones? What do you know about them? Yeah.
They don't share the same different distribution, like a different possibility.
Yeah. What kind of distribution?
Complementary.
Complementary distribution. Now you know. You actually knew set theory all along. You already knew what complements are. Right? So if we say something like, we've got a phoneme, and it has an allophone that's aspirated, and it has an unaspirated one, we say these are in complementary distribution. So this one occurs at the beginning of the stressed syllable, and this one occurs where? Not there, meaning everywhere else. Everywhere else, right? So if you take the universal set of all environments where you can get a voiceless cardinal stop, in some subset, let's call them the aspirating environment, and then you get the elsewhere environment, right? So complement, set, you already knew about set complements, even though you didn't know you knew. Complementary distribution means the distribution of T and aspirated T together completes the total distribution. Okay? So that complement that we looked at is actually sometimes called, what's it called? It's sometimes called the absolute complement. Absolute complement. Okay? And that's because it's absolute, or meaning it's relative to the universe of discourse. So D minus A equals the complement of A. It means everything that's in the universe except the stuff that was in A. Okay, so I subtracted this A in some way. We haven't really defined how to do the subtraction. And I got A complement. Okay, we can do it more generally. We can do any two sets. We can do A minus B. So we're coming to your step. Okay, so the name for this is called, sometimes this is called the set subtraction. And the symbol could be that. The symbol could also be, I always get these, it could also be that. I don't know. I'm symbol dyslexic. It's like, whatever. We use this one. I never can remember. It's this one. Doesn't matter. It's subtraction. What does it mean to subtract two sets? Okay? So it actually means the same thing as here. Here's a set of stuff. Take away from that set the members of some other set of stuff, and then you get something, get what's left. Okay? So here what you do is called the relative complement. What you do is you say, if this is a set like A, B, C, let's do the easy case. And we subtract this set. Okay? Now notice, this doesn't make sense. Actually, this is not allowed. We're not allowed to write this. That's ill-formed. That's like saying, what's 5 plus Charles, right? Equals what? Right? Well, it's undefined, right? You can't do mathematical arithmetic on a person. Numbers, right? I mean, you might have other things. You might say, like, I don't know. Let's random example. Donna plus Charles equals heart. That's different, right? That's a different, don't follow us on that. That's a different plus. But you have to have the right types. When you do your operations, things have to have the right types. Okay? So this is what we have to do. It's the set that contains ABC minus the set that contains just B. Okay? And obviously, this is just says take away B from here, and so you're going to get A and C. Okay? That's the easy case. That's the case where B is a subset of A. Right? Sorry, it's bad to use small letters and capital letters at the same time. So the interesting case is when you have some stuff in here, like E, okay? And the rule is take the first set and just take away everything that's in it, that's in the second set. And so if you obey that, what happens is you take B away and you get AC, and you just ignore the E. Okay? So it just says, look at this set, and everything that's in here, get rid of it, and that's your output. Okay, so that's called set difference or difference or set subtraction. Right? And this is sometimes called the relative complement of T and S. Now that we've been through that, we're never going to use it. We're only going to use absolute complement, and we're just going to call it complement. But it's all the same. It's just complement is subtraction from the universal set. Relative complement means I got any two sets, and I have performed this operation. Absolute complement means that the set on the left is the universal set. That's it. Okay. So we really only care about this. But this is going to be relevant when we're looking at like natural classes of sounds and stuff like that, because the universal set is going to depend on the language. Right? So French has U, and English doesn't have U. So if we're talking about phonemes or segments in a language, the universal set for French and English are different. Okay? And so yeah, the difference between absolute complement, the complement we're using is just everything that's in the universal set except what's in some other set that we've named. Okay? So if we have V minus A equals A prime, and V minus A prime equals A, and the opposite of, A union A prime equals what? Everything. Right? So we don't have to worry about if this is a set of the letters of the alphabet. If these are all letters of the alphabet. So V is A through Z. We don't have to worry about Charles and Earth and whatever, anything that's not in the universal set. Right? So we restrict our universe of discourse.